Is Markus Hermannsdorfer. I'm project leader of the Edapt project, which provides a framework for instance migration in response to eco-model adaptation. And Edapt comes from COPE, which is a research project at the Technische Universität München. Usually when you use EMF, you build an eco model which defines the classes and features. And you can use these classes to build instances of your eco model, and usually it's said that these instances conform to the eco model. But the problem is that when you adapt your eco model, then the classes and the features change, and maybe the instance that you have built with your eco model no longer conforms to the adapted eco model. And what you have to do is you have to migrate your instance. Usually, sometimes this is done manually, and by simply changing the XMI. But the problem here is that manual migration is tedious. Just imagine fixing the XMI and error prone. You can easily make errors. So what it has to be done is that migration needs to be automated as far as possible, and usually that's done by defining some kind of program, a so-called migration definition, which is able to automatically migrate all the instances that conform to your eco model from one eco model version to the next. And usually this is called, because you attach a kind of migration definition to your eco model adaptation, this is called couple evolution. That's also what COPE stands for. It stands for couple evolution. And COPE follows a number of principles. The first one is that the couple evolution is recorded into a history model, and so the migration is already recorded with the adaptation, and so this information is not lost. Then the next thing is that you divide your couple evolution into small steps, so-called couple operations. And each of these couple operations provides an adaptation and a migration definition. And so you can easily execute the couple operations one after the other, and thereby kind of record your history. Then the next principle is, for each of these couple operations you only want to specify the difference. So you want to specify the difference on the eco model level and on the instance level. And you do not want to specify the similarities like in transformation languages, otherwise you get a lot of identity rules. Then the next principle is that you can reuse recurring couple operations in order to further reduce the effort for building your migration definition. And so there are reusable couple operations, for instance rename or extract class, to help you do that. Then here you see how COPE is integrated into the eco model editor. So you can easily use the eco model editor, and you see down here the history. You see the number of couple operations that have been recorded, and when you change your eco model history, they are recorded down here. Then you can of course execute reusable couple operations through a so-called operation browser. It shows you the number of operations that are applicable. You can set parameters, and you have to fulfill a number of constraints, and then they are applied to the eco model and recorded in the history. Then you can also specify custom migrations by attaching them to a number of adaptations that are recorded into the history, and there's an editor for that, and currently such migrations have to be specified in Groovy. Then when you have recorded your couple evolution, you can generate a migrator from the history. This migrator is kind of a plugin which you can easily embed into your application, and there is an API to call the migrator from your application. And there is a number of advanced functionalities. For instance, you can reconstruct earlier eco model versions from the history, you can do an integrity check on the history, you can do a history-based comparison which is more accurate than EMF compare, and you also can identify breaking changes that need a migration attached. Then you can undo changes that you have already performed, you can replace changes with a reusable couple operation to profit from the reuse, and you can also reorder changes to specify a common migration for a number of changes. Then you can also recover the couple evolution, so when you already have a source and a target eco model, so this functionality shows you the diff between them, and you can easily apply operations to your source eco model, so to bring it nearer to the target eco model, and the diff is automatically adapted. Then COPE has been used in a number of case studies, for instance the Palladio component model or the graphical modeling framework. We have reverse engineered both histories, and we have also participated in the transformation tool contest and made the second place out of 9. Then there are a number of projects using COPE. We use it at my university for quality modeling in Cuomoco. Then it is used in Unicase and EMF store. It is used in the GMF model generator, and also it is used in a product of Marintech in Norwegia. So finally, there are a number of benefits of COPE. It automates the migration as far as possible, and it records the intended migration when adapting the eco model. And the next steps are to complete the transition of COPE to Edapt and to replace Groovy by Java to the